Hi everybody! My name's Katy and I'm part of the SEPA program at Dartmouth College. Because we'll be spending some time together this year, I just wanted to take a second and introduce myself. So I'm from the great state of Maine. Specifically, I'm from a very small town way up here on the map called Presque Isle. Now Presque Isle isn't famous for much, but one thing we are famous for is for growing potatoes. In fact, potatoes were so important to us growing up that every year we'd get 2 weeks off during school to go help the farmers pick potatoes. My mom was a teacher and so was my dad. My mom taught special ed and my dad taught band. So as you can imagine, there was a lot of music in our house. I have one older brother and his name is Ben. And I think Ben is one of the coolest people in the world. And Ben is the person who got me most interested in science growing up. So much so that when Ben went to college for engineering, I wanted to go to college for engineering, and we both ended up loving it. Ben now works as an engineer in New Hampshire, and I'm also in New Hampshire, but I'm going to Dartmouth right now to work toward my PhD in biochemistry. So what that really means is I'm a student scientist, just like you. Every day, I go to the lab, I put on my lab coat, and I do really fun experiments trying to solve a research problem that I'm about to tell you about. So, let's take a minute and talk about what I'm working on every day in the lab. In the lab, I study a type of disease called prion diseases. Prion diseases always affect the brain. Now, what's important to know about the brain is that it's made up of tiny little building blocks called proteins. And in order to properly function, these proteins must be folded correctly. You can kind of think of proteins much like little paper airplanes or origami swans. Both of those must be properly folded in order to function. Now, to describe the way that prion diseases occur in the brain, I'd like to use an analogy. Now here's a heads up. This analogy involves zombies, and I just want to be clear that prion diseases do not actually make zombies. I'm only using zombies to represent misfolded proteins in the brain. So let's look at a little animation I made to describe how prions work in the brain. So here I'm showing a little town, and we can imagine that this town is the brain. And within the brain, we have those building blocks I talked about called proteins. Here we see a bunch of normal prion proteins. Now what can happen in prion disease is that one of these normal prion proteins misfolds and becomes a zombie protein, a misfolded prion protein. This zombie protein is now able to interact with other normal prion proteins in the brain. And when it interacts with another normal protein, it can cause that protein to also misfold and become zombie-like. Now we have both of these misfolded proteins that can go interact with additional normal proteins to trigger their misfolding. And pretty soon, all of our prion proteins in the brain are misfolded and non-functional. And it's the buildup of these non-functional, misfolded proteins that cause the symptoms of prion disease, like memory loss and sudden aggression. Now, I can't wait to tell you more about my research and to get to know each and every one of you. And I'm really looking forward to that. So thank you so much for watching my introduction video, and I'll talk to you soon. Bye.